Okay, this is our topic 6. It's on chemical reactions. It says a chemical reaction occurs when one or more substances react to form products with different chemical properties. A chemical reaction is also known as a chemical change, and every chemical reaction can be represented using this chemical equation. So something really important here to note is that, a chemical reaction is you're putting different chemicals together, and then after they're put together, they're reacting in some way, and they're creating something different. But the things that are different, those new chemicals that are created, they're made up of the same ions as the ones that you had on this side. Okay. And the left-hand side, all the things you put together, those are called reactants. Okay, so the reacting things. So you put baking soda with vinegar, those are the reactants. Once you put them together, they react. What they create is known as the products. So something that you have created. And the products are now different chemicals. So you started out with something, and now you're ending up with something different. And that different thing still has the same ions from one side to the other, or the same elements, depending on if they're ions or elements. All right. So one side to the other, you're still keeping the same thing. We don't start out with sodium, and on this side we end up with potassium. Where did the potassium come from? Not thin air. So that's really important to remember when we're dealing with chemical reactions. Whatever's on this side will be on this side. We're not losing or gaining any random things. So it gives you the exact equation that I was talking about. So I was talking about baking soda and vinegar. So it shows you it here, which is a great example. So baking soda is also, the chemical formula for that is sodium bicarbonate. So that's right here. Sodium bicarbonate is NaHCO3. And vinegar is called acetic acid, and that is C2H4O2. All right. And those two things added together, we know that when we put vinegar and baking soda together, it forms a chemical reaction. And we're going to talk about that in a second, how we know a chemical reaction is happening. But basically, how we do know is for this one is that there's bubbles and bubbles of gas coming out of it. So what it does create on this other side, our products are sodium acetate, water, and carbon dioxide. Okay? So something to really note here is that when we go from this side to this side, we are keeping the same elements. The same things are here. We've got 2 carbons on this side and 1 carbon there. So we got 4 carbons. If we go to the other side, we should have 4 carbons. We don't. Wow. So this isn't even balanced. So this is not good. This is not a good example because it's not balanced. So maybe I should back up on that. But the point is, as far as our numbers, let's not go with numbers. We still have the same elements. We've got carbons on this side, and we've got carbons on this side. We've got hydrogens on the left, and we've got hydrogens on the right. We've got oxygens on the left and oxygens on the right. Okay? And we've got sodiums on the left and sodiums on the right. All right, so all of those are accounted for. The equation's not balanced, but we'll get to how you balance them and all that stuff. But this is just showing you, I'm trying to show you that what we have on one side equates to what we have on the other side. So how do we know and this is what I was talking about just a second ago, how do we know that a chemical reaction has happened? Well, we need to have evidence of a chemical change. So these are the 6 different evidence that we have to know that there's a chemical change. So the first one is a change in energy. So the temperature is a good indicator of change in energy. So if you feel the outside of the beaker and it's cold, and then when you mix something else in it, it turns warm, well, there's a chemical reaction happening there. And the same thing goes before. It could be room temperature and then all of a sudden it becomes cold. Well, we know that a chemical reaction has happened. The formation of a precipitate. And a precipitate is exactly what you see in this picture right here. That precipitate would go to the bottom. So you mix 2 liquids together and all of a sudden you see a solid in it. So a precipitate is really just a solid. The formation of gas bubbles, so you might see that in this one over here. There's bubbles in that beaker. Any sort of bubbles would be created by gas, and a lot of times CO2. Change in color. So if you see any color change, that's an indicator that a chemical change has happened. So as you start out with a white liquid and you end up with a blue, well, there's a chemical change that happened. A change in odor, so the difference in a smell. You might mix 2 things together and they don't have any smell, and then all of a sudden you have this bad smell. That would be a good indicator of a chemical change. And the last one is a change in pH. So we just talked about in the last lesson what pH is, and hopefully you remember, but just to refresh you, that we have a pH scale that goes from 0 to 14. And in the middle is our neutral zone. This side is acidic, and this side is basic. So anything, it starts out at 1 pH and changes. Well, if that change in pH, that's an indication of a chemical change. It says, note that a change in state, like a solid to a liquid, and the process of dissolving one substance into another are not indicative of a chemical change. And if you don't understand what that means, basically my best example of this is that if we have solid water, which we know is ice, and it goes to liquid water, which we know is just water. Well, between these two, from going from ice to water, or the other way around, that's changing state. That's changing from a solid to a liquid, but it's still water, okay? So when we have ice in our glass, or we fill a water bottle with ice, and then halfway through the day we don't have any ice left, it's still water. That ice was water, and now in its liquid form, it's still water. So that's not a chemical change. So when you see something that goes from solid to liquid, it could be a chemical change, but just to note here that that's not really something we can go by. We need to follow these 6 different evidence of chemical change. Okay. So how do we predict solubility? Well, first of all, we need to understand what solubility is. And solubility is basically being able to dissolve in something else. All right, so maybe you've before dissolved sugar in water, you've made juice, or you've taken juice crystals and you put them in water, and all of a sudden you don't see the juice crystals anymore. Well, that's dissolving, and that means that the juice crystals are soluble. So the word soluble means that it can dissolve. Something that is, I guess, in this case, they call it low solubility. That means that it doesn't dissolve. So you might mix iron filings in water or something. That's not going to dissolve, so that we would say that's low solubility. Okay, so here's a table that is used to predict whether two substances will react to form a precipitate or whether they will dissolve when combined. So that big word precipitate, what that means is if we mix two things together, and normally by things I mean liquids, in this case, and a solid appears. Okay, so this table right here is going to show you, and I will post a table for you with this lesson. But basically this table tells you, you can use it sort of like a multiplication table to show you whether things will dissolve in one another. So let's I'll try and show you sort of how this works. So let's say I want to know, I have some chloride. So that's the very first one here. So chloride, this table is not the greatest, but basically what it's saying here is high solubility, so that's that it dissolves. It says most things dissolve in chloride. Okay, but the things that don't dissolve are right here on the bottom. So the things that don't dissolve are silver, lead, titanium. That says TL. I don't know what that is, but I think they've got it messed up. We've got mercury and we've got copper. So if I had a reaction where I mixed copper with chloride, that would create copper chloride. And we know, hopefully you know, that copper chloride, you wouldn't know this, but copper chloride, something that has copper, is going to be a solid. So that would become a solid, and that does not dissolve in one another. All right. So just looking at this table, it sort of explains to you what can dissolve in what. And this will become clear when you try and do some of these questions. So we'll probably do some examples, I hope, right here. So it says a chemist mixes a solution of lead nitrate, PbNO32, and potassium iodide, Ki. Does a precipitate form? If so, predict the precipitate. Okay, so this is like almost going beyond what we already know, but I will explain how this works. So they're saying basically that if we mix this with this, these would be our reactants. It's asking if we mix those together, would a precipitate form? Well, some background information for this question to even know how to do this is that we would have to know what the heck the products are. And you can actually predict this. But we haven't talked about this yet. So this question I'm saying is a little bit beyond us, but I will explain it right now. So when you have like a compound there and a compound here, you got 2 ions and 2 ions. When we mix them together, what happens is they switch partners. So lead was with nitrate and potassium was with iodine. And when we mix them together, they actually switch partners. So lead was with nitrate right here, but now on the other side, he's going to go with iodine. Why iodine and not potassium? Well, it's got to be a metal and a non-metal. And lead is a metal and iodine is a non-metal. And just to show you I'm not making this up, if we go over to here, we see lead is number 82. That is a metal. And then to the right of that, iodine oh, it's basically right around the same area, is a nonmetal. It's got that N, that light green there that we've got. Okay, so we need to always put metals with nonmetals. You would never see two metals going together. That's two positives, and it just doesn't work. All right, so back to this. So basically, we're switching partners. So whenever you see two elements going together, or sorry, two compounds, they will, when mixed together, switch partners. So lead was with nitrate, and now they're going to be with iodine, if I can not go off the page. Okay, so that means that if lead goes with iodine, well, nitrate is going to have to go with potassium. Okay. We always write the positive one first and the negative ion second. Okay. So now we've got PBI and KNO3. So now the question here is, this whole question says, well, does a precipitate form? And a precipitate forms only when something is not able to dissolve in one another. So precipitate, if we go back to that last slide, precipitate means that produces a solid. And for our table, that really means it is low solubility. So what we need to do with this information is we've got to go check these. We've got to go and check PBI, and we've got to go check KNO3. Okay, so let's go check PBI. So we go back to this table, and you notice that along the top here, we've got anions. So anions are our negatives. If you remember, ants are negative. So we're looking at our anion. For ours, our anion is I. It's iodine. PB is our cation. That's our positive one. So we need to look for I. And I can see it right at the very first column there. Is I. All right? So we need to figure out if it is soluble with lead. And I can see right now that lead is right here, and lead is a low solubility. So if I go back over here, underneath this, I'm just going to write, LS. I hope you understand what that means. Low solubility. More just for spacing. And then we need to do the same thing with KNO3. So NO3 is our anion. So we're going to look up NO3. We see it right here. And it's telling us that everything with NO3 is high solubility. So there's nothing that NO3 doesn't dissolve. So over here, we're going to write, I don't know, I guess I'm putting HS, right, for high solubility. HS. Okay. So that's what they're doing there. They've explained it a little bit differently. They're going through, okay, well, this breaks down in water. These are the possible combinations of ions. And then according to the chart, PB is insoluble with I, which we found out. That's why we wrote low solubility. Therefore, a precipitate will form. Okay? So the question's asking, does a precipitate form? If we're going to write this out, yes. Precipitate forms. Okay. So that is that. Let's go on to the next one. It says predicting solubility in water. It says we can also use the solubility table to predict whether or not an ionic compound will be soluble in water. So it says, will this compound, BaOH3 or BaOH2, dissolve in water? So first we've got to locate the OH on the solubility table and then look down the column to locate Ba. Because Ba has high solubility with OH, this will be soluble in water. So putting those two together, we can see that it's soluble. So they were looking for OH and then Ba, and they found out high solubility. Okay. So that's how we do that. So we're gonna do some practice here to try and do this stuff. Sorry, I just got to let my cat out of the room. So it says determine whether each of the following compounds will react to form a precipitate. So just like I did in the other question, these are two elements together and two elements together. When we have something like that, they switch spaces, they switch places, they switch partners, dance partners, whatever you want to say. So Na was dancing with OH, and now they want to dance with Cl. Why Cl? Because Na is the cation. It needs to join an anion. The only anion it can join is Cl. Okay? You can't put NaCa. Those are two metals. Two metals don't go together. It's just how it is. Okay? So Na and Cl. Perfect. And then the second piece we got here is OH and Ca. Okay, so those will go together. Ca goes first and OH. I am writing this like this only to balance it, but it's really not too important to you. Remember back a couple lessons ago, I think topic 4, we would have talked about balancing when we're writing ionic compounds. So if I wrote it like this, Ca has a +2 charge, OH has a -1. So we would have to do this crossover method, like I showed you before, to get CaOH2. See, this 2 goes down below the OH. Because it's a polyatomic, you need to write those brackets. So I was, sorry, just writing it like that, not really explaining, just because I've done this for so many years that I just automatically balance as I'm writing stuff. The NA's balance, it's +1 and -1, so we don't need to worry about balancing that one. Let's do this one as well, and then we can look them up. So Cu is going to join with S. So Cu in this case has to be +2, and this is -2, so it's balanced. And then Al is aluminum. That's going to go with chloride. And aluminum is +3, and chloride is -1. So this 3 is going to have to go down there. So it's going to end up like that. Okay, so that's the elements balanced. The whole reaction is imbalanced. We haven't got there yet on how to do that. But we're going to look these things up. So let's do the very first one, which is NaCl. If you don't know, NaCl is salt. And I hope you guys know, just not even by looking at this table, that salt will dissolve in water. If you put salt in water, it's going to dissolve. That's what's in the ocean, for example. But we will look it up just to show you that this table works. So we look for the anion. We're doing NaCl, so we're looking at our Cl there. And then we move down to look for Na. There's no Na down here, which means it must be in the ones that aren't written, which is high solubility. So we're not crazy when we say salt dissolves in water. You've probably done it before. It dissolves. So I'm going to write HS for high solubility. Oops. I was trying to do that. All right. And then our next one, CaOH2, we've got to look up calcium and hydroxide. So hydroxide would be our anion. Just erase all those. So hydroxide is our anion. We've got to look down for calcium. It says group 1, and then all these ones are high solubility. Let's just double check. Calcium is actually not in group 1. Group 1 is the very first column with hydrogen, lithium, all that. So calcium is in group 2, which means that it is not soluble. So the ones that are not would be low. Okay, so that's going to create a solid. So we're going to say low solubility for that one. Sorry, I keep hitting that side thing. Perfect. All right, so high solubility for NaCl, low solubility for CaOH. Let's do our next one. Our next one is CuS. So we're going to look for S on that table, which is our anion at the top, and then we can work our way down. We see S is right here, and it's going with Cu, which is copper, right? I believe. Just double check that. Copper. So copper is not in group 1 or 2, so it would be low solubility. I can show you where copper is. It's in group 11, right? Number 29. Okay, so not group 1 or group 2. So that becomes low solubility. Okay, and then let's do one more other color. Our last one here is AlCl3, and we gotta look up Cl, and that's our anion. So Cl is right there, and then Al is aluminum. There's no aluminums here, so it's got to be in the most section. Okay, so that would be high solubility for aluminum chloride. So we write HS, and then that. Okay, so that is how we do that. So the question's asking which compounds will form a precipitate. Well, in this case, we've got aluminum chloride is the one that's forming the precipitate. And no, sorry. Not the one that's high solubility, the one that's low. So this one will be forming a precipitate, and this one. Okay, so those are the two that we would consider to be forming a precipitate. I think it's Okay, so the calcium hydroxide and the copper sulfide. Determine whether each of the following compounds will dissolve in water. So we just need to look these up and see if they are compatible with each other, and if they are, then they will dissolve in water. So we're looking for magnesium sulfide. Just to remind you, magnesium is a +2, sulfide is a -2, so this compound is Mg. Why is this skipping? MgS. This one over here is zinc, which is a +2, and nitrate, which is a -1. So if we're going to write this out, it would be ZnNO3 2. Because we're crossing over. These ones are balanced, so we're good. This one we've got to bring an extra 2 to balance that out. Okay. So now let's look these up. We got to go MgS. So we go on to our solubility table and look up MgS. We're looking for S first because that's our anion. So S is right there. We're looking for Mg. Mg is in group 2. I'll show you. Mg number 12. It's in that second column there, which means that this is high solubility, right? Group 2, it's in that high solubility frame. So we're going to write that right here. So if it has high solubility by itself, can't write. If it has high solubility with itself, that means it's going to dissolve in water. So, good one, dissolves in water. This next one, ZnNO3, so we're going to look up NO3. Zn, so all and none. So there's nothing that won't dissolve in NO3. We did that one before, which means that this question is going to be high solubility. Okay, and it means it dissolves in water. Okay, so if you put both of those things into water, they're going to dissolve. I'm going to stop right there just for now at the energy change. So there should be, let me just double check. So we're on topic 6. So if we go on to the topic 6 assignment, right now, after this video, you should be able to work on question 1 to 3. So I will write that on here. So from here, you need to do questions 1 to 3, right? We will continue and go through this whole assignment, but that little section pertains to question 1 to 3. Please let me know if you have any questions, and please keep doing your work. We have lots of things to get through and very little time remaining. Okay? Have a good